Okay, let us begin again. Okay, so testing for the linearity of regression means that we are testing the linear relationship between our x and y. Okay, we would like to see whether the R that we have got telling us the strength and the types of relationship between y and x, whether the what we call the correlation exists or not, and everything. We can further test for the linearity of the regression, where we would like to know at the end of the process whether our x is actually has something to do with our y, or is there any relationship between y and x that we have chosen for our modeling using the regression. And to test for the hypothesis testing, you can use either the t-test or the f-test, but in our case I would like to concentrate on the using of the f-test, because this one is generated using Excel. Okay, so it will be easier for us to discuss. Last time, hypothesis testing for the correlation coefficient, we are using the t-test. Okay, so in this case, for the linearity of the regression, we are using the f-test because it is already generated using the Excel. So what kind of procedure that may be involved in testing for the linear relationship between y and x? As usual, we are going to have the 5 steps. Okay, and the 5 steps include: the first one, determine what will be the hypothesis statement for our test. Since we are testing for the model, this is our model, estimated model using our sample. Since we are testing for the linearity, that is why we are focusing at the coefficient of our x. That will be our beta 1 hat. Okay, so our beta 1 hat is our what we call coefficient for our x. And to test for this particular model, that's why we choose for the beta 1 hat. And you can see from the statement of our hypothesis, okay, we can see the null statement would be beta 1 is equal to 0. And alternative beta 1 is not equal to 0. What does it mean by beta 1 is equal to 0? Beta 1 is equal to 0 is meant no relationship between x and y. Beta 1 beta 1 not equal to 0 means exists linear relationship between x and y. My question will be, why we are using beta 1 instead of beta 1 hat class? Can someone answer me? Why we are testing beta 1 hat, beta 1, not beta 1 hat class? Someone please? Why we are
Because we
testing?
want for the population, we don't
Yes,
want to simple.
yes. Since we are trying to make conclusion for our population, and we are using our sample data to conclude for our population, that's why we are testing for the beta 1. That will be the coefficient of our real model. Okay, so that's why we are using beta 1. Now, second procedure would be compute the critical value. In our case, we are using F. Okay, using F, so calculate the F test. So calculate. But in our case, we are getting the value from our Excel. Once you have got your this one is not the calculated, sorry class. This is the F critical value. So F critical value would be, hold on, my pen is not working. Okay. So for F, it will involve 3 parameter. That will be alpha. And then the degree of freedom for error. So sorry for the regression, sorry. Okay. And the degree of freedom for our error. So this will be F alpha. Usually the degree of freedom for our regression would be 1. Okay. And the degree of freedom for error would be n minus 2. Okay. So that will be the F critical value for the second step. For the third step, since we are comparing our F critical value, we are comparing this value to the calculated F. So here, the third will be F calculated. Okay, finding the F calculated. And in this case, we are using our Excel. Okay, now this one, use table. So this one, you are going to have to find it on your own. Use what we call table. Is there anything, is someone writing something, is it? Because I can hear the, is there anything? No? No. Okay, no. Thank you. Okay, let's continue. Okay. So I've calculated the third step is from your Excel. F critical value is using your table. So you have to find it on your own. Knowing what will be the parameter, you can find what will be the F critical value. And the fourth one will be determine the rejection region, or whether you need to reject or fail to reject the null hypothesis. So in this case, since we are using the F, so how does your F distribution looks like? If you look at the appendix that I've provided to you in chapter 3, if I'm not mistaken, F distribution is something look like this. Okay, the minimum value would be 0 and the maximum value could be infinity, positive infinity. Okay, so for the T distribution, almost like the normal table, okay, except that this is on using the T distribution. And this is for F distribution. And for F, okay, since we are using our F critical value and F test, so where does my F critical value lies? Okay, from your table of F, you can find your region of alpha. So this is your alpha. And based on your alpha value, you can find your F critical value. So your F, that will be depending on the DF for regression and DF for error. Okay, so this is your FCV, critical value. Okay, where does your F test then? Your F test could be lies in this particular area, F test, or it could be somewhere inside your rejection region, depending on the calculated F that you have got from your calculation. Okay, so in this case, this is what we call the non-rejection region. Okay, if your F test of your, that would be your F calculated. So I think it would be easier for me to write down F calculated. Okay, F calc. F calc. CLSC means that calculated. So if your calculated F falls within the non-rejection region, here means that you will have to fail to reject null. If your F calculated value falls in the rejection region, so here is the rejection region. If falls in the rejection region, then for this case, reject null hypothesis. Okay, so that will be the way we can make our decision whether we fail to reject the null hypothesis or we reject the null hypothesis. So the statement here is very important in your decision making. Okay, and there will be a second way on how we can decide whether we have to reject or fail to reject. I will share that later on. Okay. And finally, the last step would be um, making conclusion for your hypothesis statement. Okay. So in this case, if we reject the null hypothesis, we reject the null hypothesis means that we have sufficient evidence to conclude that there is a significant relationship between our x and y. So in your case, do not write x and y. Write what will be your x and y that you have got in your equations. Do not put x and y only. Okay, you have to write down what is your x and what is your y inside your conclusion. Okay, so far, do you have any question, class? Any question, class? Any question? Is it okay? Understand? So you are going to use this for your assignment. Okay. So you have to know how to make your conclusion, and of course, you have the way you make your conclusion will be based on the problem that you are investigating. So I think for chapter 5, the assignment is I think is can be said as easy, but in terms of making to relate to your problem that you have in hand that you are going to choose afterwards, so that will be the most challenging part. Okay, because you have now your what we call your problem in hand, and you know what to do, but your discussion would be not only on the process but what based on the problem that you have in your assignment later on. Okay, so that will be the difficult part of your assignment too. Okay. Okay. I'm actually before I forgot, I'm actually doing my attendance. So those who got your attendance ready, you can start filling your Google form. I'm also performing my attendance. Hold on. Okay. Okay. Now let us look at one example. Okay. Now we have our score in Math 1 and Math 2 last time. So let us look at example Math 1 and Math 2. Okay, so we have discussed this last time. Okay, we have Math 1, we have Math 2. And then you have to estimate the linear model for Math 1 and Math 2, and then predict if your Math 2 is 60, what will be your prediction of Math 2 score if your Math 1 is 60? So last time we did using Excel. Okay, so if you can remember, this is your Excel. Okay, this is marked for your Math 1, this is marked for Math 2, and then we use our Excel to come up with our some of the value that we need to have for our linear model, and to see whether what will be our relationship, what will be the strength, and so on and so forth for this particular example. And from this particular uh, what we call scatter plot that we have along with the line, we have got our model here. Okay, so our y hat is equal to beta naught hat is 0.8237. Sorry, beta 1 hat is equal to 0.8237, and beta naught hat is equal to 12.306. So this is the model. Okay, by using this model, okay, you need to predict what will be the y that will be what will be the score of Math 2 if the Math 1 is 60. Okay, last time we discussed about this. So in our discussion, okay, we can see that by using this particular model, we can find the where is the okay, here. Okay, By using this particular model, we can find what will be the Math 2 score. Okay, by using Math 1 score that is 60, we can find the Math 2 score that is equal to 61.73 or 62%. So that is your prediction value for Math 2 using prediction value, using the X value of 60. Okay, so we further investigate whether this particular linear model is actually proven to have linear relationship. Okay, so by using alpha 0.05, okay, let's just use these particular notes to discuss, and then let us see another example where we have to do from the beginning using the Excel. Okay, for the discussion purposes, let's just use this particular notes. Okay, the first step would be, okay, the statement of your hypothesis. We are testing for the y is equal to, y hat is equal to, the model would be, let me just take two significant value, 12.31, 0.82, 12.31. So we are testing this model, 0.82 plus 0.31 ke? Saya silap ke? This one is X. 8231. 12.3182. Oh, terbalik. 12 point. Daripada saya lupa. Okay, the model that we are testing is this particular model. Okay, 12.31. Zero 0.82x. Okay, so we have this particular model for our Math 1 and Math 2. So this is your Math 2, Math 1, and this is your Math 2. Okay, based on the findings, we know that this particular model has linear relationship, quite strong. Okay, if we haven't test for the correlation coefficient, you can test that. Last time I did mention for you to test the particular hypothesis testing for the correlation coefficient. But now we are testing for the linear relationship between Math 1 and Math 2. Whether our X that would be Math 1 has something to do with our Math 2. So our statement as usual will be beta 1 equal to 0 and beta 1 not equal to 0. Okay, so from this particular example, since it is using the T, so I'm using the F. Okay, so for F alpha 0.05, and then we have degree of freedom for the regression is 1, and the degree of freedom for n minus 2 is 4. Okay, so this is F critical value. So using our table, okay, so using our table, so let us look at our model just now. So where do I get this particular value? Sorry, since the n is equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10. Okay, so here is n minus 1. This one is n minus 2. So this one is the error. So this one is the regression. So that's why I'm using this particular 2 value. Okay, so 1, 8. So 1 and 8. So this one would be 1 and 8. Okay, look our F distribution 0.0518. Go to your F using your alpha 0.05. So look for the correct alpha. Do not use wrong alpha. You have 0.01 and 0.05. Since you are using your 0.05 and our degree of freedom of our error V1, yeah, it is 1 and V2 is equal to 8. So your F critical value is 5.318. 5.318. So here is 5.318. Okay. And then for the calculated F calculated, you can just refer to your Excel. Okay. So this is your F calculated. F calc. So 62.58. Your F calc is 62.58. Okay, so you have got your F critical value, you have got your F calculated value. Then the fourth one would be making your decision. Since we are discussing about our F, okay, and our F critical value for 0.0518 is 5.32. Let's say I take 2 decimal point. 5.32 is your F alpha. And where is your alpha? This is your alpha. All these are alpha. And what is your F calculated value? 62.58. Very big. Okay, so in this case, your F, let's say this is your F calculated. That will be 62.58. Okay, and obviously it falls in the rejection region. So in this case, our decision will be reject null hypothesis. Because F calc is greater than F alpha. Okay, that is your reason. So in this case, since we are rejecting our null hypothesis, means that, okay, we reject this null hypothesis means that we are going to make conclusion on our alternative statement. That is why, okay, we reject null hypothesis. So the score Math 1 has linear relationship to the score in Math 2. Okay, so this is the simplest way on how you can make your conclusion. And but for the most what we call the most precise way on how to make your conclusion would be, since we reject the null hypothesis, we can say that we have sufficient evidence. We have sufficient evidence to conclude that Math 1 and Math 2 has significant linear relationship. So that would be the most, I would prefer that one. We have sufficient evidence to conclude that Math 1 and Math 2 has significant linear relationship. Okay, so that would be our conclusion. Now, we only discuss one way on how to make your conclusion based on the F calculator and F alpha. Now, what will be the second way on how to make your conclusion? That will be based on this is the first way, and the second way will be compare alpha and p-value. Okay, so where is my p-value? I know where is my alpha. This is my alpha. Okay, this is our alpha. That will be the probability value where my F alpha begin. But the question mark, where is my p-value? P-value is reflecting the probability value beginning from the F calculated. So that would be, if I take the green region, so this is where your p-value located. So this is the p-value. So the way we make conclusion is that if your p-value is smaller than your alpha, then we reject the null hypothesis. Okay, so we reject the null hypothesis. Okay, it's as simple as that. Okay, you can use either the significant value or the F alpha and F calculated. In fact, your p-value, in fact, your significant value is given in your table. So here, if you can see, this is your significant F value. Okay, very small. Okay, if I can write down, this one is actually 0.0000473. This is your p-value. Very small p-value. Okay, so everything is provided inside your ANOVA table that you generate using your Excel. It's just that you have to understand what does regression means, what does the residual means, what does this F means, what does this significant F means. Okay, so it's just that you have to make your knowledge aware of what will be the things that you need to conclude from the given analysis from your Excel. Okay, any questions so far, class? Is there any question so far? So you can see the conclusion or the summary of how you can use the F test for your hypothesis testing for the linearity of the regression. Okay, so you can also have the step for F as what we have discussed just now. So you have also the general form of your ANOVA table. Okay, and then you can see how you can make your Excel using this. Okay, so if let's say before we do this particular example, exercise 5.1, let us look at the example given to you in this particular questions. The manufacturer of cardioglide exercise equipment wants to study the relationship between the number of months since the glide was purchased and the length of time the equipment was used last week. So we are talking about a health equipment, cardioglide. Okay, so this cardioglide, the company wish to investigate whether there is a linear relationship between the equipment and the length of time the equipment is being used last time or last week. So let's say you have been given the ANOVA table. Okay, so you can also have your coefficient table. Okay, and if you can see, this particular table is exactly what you have in your Excel. Just let us look at this particular table class. You have the ANOVA table. Okay, you have the ANOVA table. You have the coefficient table. What does that mean? If you can refer to your Excel, you have also the ANOVA table. You have also this coefficient table. Intercept, math 1. Okay, and if you can see from this particular example, is actually the information that is useful for you would be this one. Okay, this one constant is reflecting the coefficient for your what we call interception value in at y value, and months is your x coefficient, and from this you can what we call take out the information to develop your model. So your y hat is for this particular exercise would be y hat is equal to the coefficient of the interception, that would be 9.939, and the coefficient for x negative, so negative 0.637x. So this is your linear regression model for this particular example. And then you have your regression, you have your residual, that is your error, and then this is the degree of freedom, and then this is your F calculated. Okay, so from this, if let's say the first question determine the regression equation, so this is the first question. Second, test for alpha 0.01. Okay, so test for alpha 0.01. We begin with the statement of the hypothesis. H naught will be beta 1 is equal to 0. Alternative, beta 1 not equal to 0. First step. Second step, FCV. FCV, that would be F 0.01, 1, 8. Okay, 0.01, 1, 8. Look at your F distribution table for alpha 0.01. For alpha 0.01, my degree of freedom of regression 1, degree of freedom of error is equal to 8. So I get 11.26 as my F value, F critical value. 11.259 or 11.26. So 11.26. My F calculated is equal to 17.30. Seventeen point 30 or 03 30. Okay, number 4, make conclusion. So let's say I'm using my FCalc and FCV. So my FCV is 11.26. So this is my alpha 0.01. This is my FCV 11.26. And my F calculated is 17.30. So my F calc is 17.30. Since my F calculated is smaller than my FCV, so here we reject the null hypothesis. Or if you wish to use your significant value, you can just say since p-value, this is my p-value, okay, is smaller than alpha, so we reject the null hypothesis. Okay, and number 5, making conclusion. Since we are talking about the equipment and the length of time the equipment used, so in this case we can say that, okay, or if you wish to use the what do we call that, the significant value, so we have sufficient evidence to conclude that the number of month equipment is being purchased and length of time the equipment is used we have sufficient evidence to conclude that the number of month equipment is being purchased and length of time equipment is used has linear relationship. Okay, so that's the whole process in making conclusion whether this particular equipment has linear relationship between the length of time the equipment being used. Okay, class, is there any questions for this particular case? Class, do you understand this, class? So you have to know how to perform this particular what we call test, and then what most important would be your conclusion for this particular investigation. Okay, class, are you all with me? Seems very quiet, everyone. Okay, is it okay? Understand, class? Okay, Ahmad Nazrin, thank you. Why you cannot just throw out your voice? It would be easier. Okay, so let us continue with the last exercise. Now you are given this exercise 5.1. The owner of a small factory that produces working glove is concerned about the high cost of air conditioning in the summer. Keeping the higher temperature in the factory may lower productivity. So during summer, he conducted an experiment with temperature setting from 68 to 81 degree Fahrenheit and measure each days of productivity, which produced the following table. So the company wished to investigate whether keeping higher temperature or lower temperature will increase the productivity or will increase the production of glove. So they take certain days of production and what we call record some of the findings. Okay, so in this case, the number of days involved would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 days of experiment where the variable involved include temperature and the number of pairs of glove produced in 100. In 100 means the actual value is 3,700, 3,700 glove produced. That is what meant by in 100. Okay, so for the calculation easiness, so everything put in terms of 37, 37, 32, blah, 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 and so on and so forth. Okay, but the temperature in Fahrenheit. So you have the question, find the regression model, predict the number of pairs of glove produced if x is equal to 74, means that you have to use your regression model and find the prediction value of your y hat using your x equal to 74. And then compute your Pearson correlation coefficient. Okay, so what can you say about the relationship between the two variables? So what is Pearson correlation coefficient, class? Which value is that, class? Do you still remember? Do you still remember, class? Is this R or R squared? This is your R, right? So find your R. Okay, what can you say about the relationship between the two variable temperature and the number of pair of glove produced? And finally, you need to do some hypothesis testing for this particular model using alpha 0.05. Now class, I want you to what we say that copy this table to your Excel. I want everyone to use your Excel and do the analysis using your Excel. Can you do it now, class? Let's say you have this. This is your data. I give you 1 minute to copy to have your Excel ready, class. Okay, thank you. Done, class? Are you done, class? Hello, class?
Yes, Doctor.
Okay, done. Ready with the data? Now, find the regression model. What would you use to find your regression model using your Excel, class? What would be the one that you need to use to find your regression model? Easier way.
Go to analysis data.
I know, data, and then?
Analysis. Go to the regression one. So feed the value x and y.
So the Y is actually here. So correctly choose your Y. Correctly choose your X. Label included. And your alpha that you are using is what? 0.0 what? 0.05. So 95%. confidence level 95%. Okay, so identify the output range that you wish to have your data result, and then click OK. What happened? Where is my analysis? Data analysis, regression, okay. Then okay. Okay. There's something wrong with the input range. Something wrong here. Hold on. I'll just clear up everything. Cancel. Cancel. Okay, my cursor, see, my cursor is not moving. Hold on. I don't know what happened. I need to shut down my Excel first, class. I don't know what happened to my Excel. Don't save. Okay. Okay, I have my equation here. Control C. Control V. Okay. So go to your data. Go to data analysis. Go to your regression. Okay. Identify the Y. Identify the X. Labels included. Confidence level 95. Output range. Somewhere over here, let's say. Okay. Okay. So you can see you are being given some of the information for your example. And then for your exercise. Now, but in this case, you did not get your model. So how do I create my model? You can have your model from here actually. But if I would like to see my model in terms of the scatter plot, what would I use, class? Go to data again. Go to what? Is it data or is it insert charts? Insert chart, right, class? So choose this scatter plot. Okay, but since I did not include my data, so let's say we do again. Okay, highlight your data, go to insert, go to scatter plot, and then you can modify from this particular, you can add the X name, Y name, the axis name. But in this case, let's say I just want to include the trend line. And then I would like to have the equation to be included. Okay. Include R, include equation. Okay. So I've got my equation. And then you can adjust. Okay. Just for the purpose of our discussion, quickly. Okay. So you can hear from here, class, you can see that the interception is the coefficient of your X is negative 0.5121. See, obviously the same. So the temperature coefficient, okay, the same as this one. And the interception is 73.657. Okay, almost the same as inside the scatter plot. Okay, so that will be the interception. And the reason why, class, you have this particular what we call scatter plot to be included in your analysis is that, why, class? Because in the regression statistic given to you, okay, these two are very important, because these two is the one that you can use to answer the question given to you. Last time I did mention about this R and R squared. Okay, multiple R refers to your correlation coefficient, Pearson correlation coefficient, or simply say, as what we have discussed last time, we call it as sample correlation coefficient. So this one is your sample correlation coefficient. Since in our generated analysis, it will not be given in positive or negative. Okay, so you have to be very careful. Once you have seen your scatter plot here, you know that this X and Y has negative relationship. But the R given to you is positive. So be careful, because the negative value is not automatically given to you. So you have to see the scatter plot that you have for your problem, just to know whether this relationship has positive or negative linear relationship. So that's why you have to have this scatter plot. Okay, so by looking at the coefficient of your X negative here, it can help also to know whether this particular R is actually negative or positive. So in your case, like next time, class, when you generated your summary output for your regression analysis, make sure that in order to make conclusion for the R value, you have to see for your scatter plot or your coefficient of your X to know whether it has negative or positive linear relationship. Clear or not, class, for this particular multiple R? Class, is it clear? Is it clear, class? 100 and... Okay, so you have to make sure you are referring to the correct value. So what is R square? Okay, if multiple R, okay, multiple R is actually talking about R. R, the sample correlation coefficient, or Pearson product moment correlation coefficient. Okay, remember, Excel only give value. Negative or positive need to be identified on your own. So multiple R only tells about the strength of your the relationship between X and Y. What about the R square? R square talking about the coefficient of determination, talking about the contribution of your X to your Y. Contribution of X to Y. So you have to know which one is which. Okay? And then what next? Okay? So the question asked would be, find the regression model. So the regression model from the Excel, you can see the regression model is this one. So if I were to write down, okay, your Y here, your Y hat is equal to 73.6579 minus 0.5121x. Okay, predict. So can you predict, class? What is your Y hat if your X is 74? What is your Y hat, class? Can someone please calculate? What is the value, class?
35.7625.
35.7625.
7625.
76 lah. Okay. So since this is in 100, Okay, so be careful with your answer. If it is in hundreds, so make sure your answer is also in hundreds. Okay, so if I were to make it in hundreds, so it would be y hat equal to 3576. So that would be your number of glove produced if the temperature is equal to 74 degree Fahrenheit. So this will be your final answer. Next, C. What is your R? Your R in this case, what is your R? So look for your R. R is equal to 0.9248. So let's say we just take 2 decimal point. So it should be negative 0.92. Okay, negative 0.92. So what can you tell from this particular value, negative and 0.9? Can someone answer me, class? You know it has negative relationship, and is it strong or weak relationship, class?
Strong.
What was that?
Strong.
Strong, because the value is almost -1. So what you can say, about the relationship of the two variable, we can say that temperature and number of glove has strong negative linear relationship. So your perfect comment would be important for your marks later on. Okay, so if you just say strong negative relationship without the linear, so mark will be deducted from your answer. So please be careful with all the terms, the correct terms that you need to use for your conclusion. Okay,
Doctor,
and
I have a question.
yes,
How do you know the value is strong? I mean, what is the range? Is it from
okay,
zero
yeah,
point 0.8 or 0.7?
okay. Okay, thank you. Last time we have discussed that R range from 0 until -1 to +1. Okay, if let's say the middle value is 0.5, okay, if let's say you wish to use, okay, 0.7 and above as strong, it is acceptable. And if you can say, if you want to use 0.5 as quite strong, just to differentiate between 0.5 and 0.7, you can say quite strong. So the word using the terms that you use will be reflecting your answer. So if you say there will be no cutoff point to determine what will be the beginning value for strong relationship. Sometimes 0.7 also considered as strong, depending on the problem that you have that you are doing or discuss. Okay, but most of the time 0.7 and above are considered as strong. Okay, so less than 0.7 you can also say as quite strong, considerably strong. You just use the correct terms to differentiate between the strong, quite strong, weak, very weak, and so on and so on. Okay, did I answer your question?
Yes, doctor. Thank you.
Okay, thank you. And the last part, okay, hypothesis testing. Okay, so just I don't want to use step by step, looking at the Excel result. Okay, just let us make our conclusion from here. Okay, we know that let's say I put my ribbon first. Draw. Okay. Okay, we know that we are using this value, use this value and this value. So we know that our F alpha is 0.05, 0.05, right? And then we have 1 degree of freedom for regression and 6 for degree of freedom of error. So 0.0516. Look at your F table, 0.0516. So we have 5.987 or 5.99. 5.99. Your F calculated is 35.46. If we were to make decision, okay, 5.99, your F alpha is somewhere over here. If your F calculator is 35, somewhere over here. So obviously here we reject null hypothesis. So when we reject the null hypothesis means that we have sufficient evidence to conclude that these two variables, that is temperature and the number of glove produced, has significant linear relationship between them. So that will be your conclusion for this particular problem. Okay, class? Is it simple, class, using Excel without no calculation? Manual calculation for every of your process in simple linear regression. Everything okay, class? Is it okay? Can someone please comment okay or not?
Yeah, okay.
Okay, thank you. That means we have finished our lecture for simple linear regression. That will be last part or final chapter of our SMQ 272 or probability and statistic